Hello and welcome to TidyX episode 163. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks as always checking in with us at TidyX. This is episode 163. We're talking about Shiny still. Go ahead and like and subscribe on that YouTube channel. Drop your comments, questions down below. As always, if you appreciate our work, we do have Patreon, and if you'd like to contribute to the show, we're always thankful. That said, we'll jump into 163. Last week we were talking about doing some stuff with Shiny where we had Ellis wrote a neat little Shiny app that was basically extracting game information across seasons from user-defined parameters, and it was making a call out to hockeyreference.com. This week, we're going to do something on the individual players themselves, and then we're going to talk about in future episodes how you link up different Shiny apps and things like that. So what I've got here, what we're looking at is our Shiny app that we're going to go through. So it's a simple, you're just basically looking at a hockey reference page that's player stat based. You can select as many players as you want. And the cool thing here is, again, we're talking about making our Shiny apps dynamic so that we can allow our users either to pre-populate to get to the Shiny app with the information they want, or, which we talked about, I think, in episode 159, or go from the Shiny app out to a different source. And so here, what we have is the link that then takes you to that player's actual page. So if you had to get other information, prior seasons, information about where they went to school, information about their age, etc., it's all available right here. You can grab that information, click out to their links, and there you see all the seasons for Claude Garreau, and you can get all of his information from there and play around. So that said, we're going to jump into the episode on how you build this dynamic clickable data table within Shiny. We've got some packages at the top. Standard fare for us, Tidyverse, we're loading rvest so that we can actually scrape and get the data. Shiny, and then the DT table, which is what produced that table that you saw on the Shiny app. Last week's Ellis's version was actually calling out dynamically from the server to the web page based on the user parameters, and then it was observing that event and throwing that information back to the user so they had choices. We're going to do that with this app in the future when we talk about linking it up. Right now, we're just going to scrape the web page a little bit and get into that a little bit more than we have in the previous episode, because there's something extra that I had to do here to make this work. So the first thing I wanted to get was the actual skater data. So we just read that HTML from hockeyreference.com, and we're going to take that first table there. We're going to convert it into a table in R. Again, super props, super thanks to the people at sportsreference.com, because this is really, really easy scraping. They make it super accessible for us. We're going to scrape that skater data in. Now we have a data table inside of our R session here. There's our skaters. Yeah. And so that's the whole table that we saw there. We're going to have to do a little bit of cleaning. We can see that the first row is actually the column names. So I do a little bit of cleaning up here. So I'm going to take the column names and name the first row the column names, and then just dump that first row out. And then I also will use janitor clean names so that I can get rid of all of the special characters and weird stuff like that, spaces. And then because this is if you look at any of the sports reference tables, after like 20 or so individuals, it repeats the headers for convenience, obviously, viewing. But for us, for our purposes, because the table is dynamic, people are going to select as many as they want. It's not going to be a problem. So anytime that we see that, anytime player equals player, we're just going to chunk that row out and just get rid of it. So we've cleaned up our data. Now there's one thing here that we need in order to make this go and reach out to that web page, and it's a URL. And so if we go back to Hockey Reference and we just kind of hover over a name, we'll see at the bottom left, we'll see what appears is a link. And that link is hockeyreference.com/players/ and then information about the player. It's usually like the first 3 letters of their last name, the first 2 letters of their first name, and then a number. And underneath each of these links, because these links are hot, is the information that contains what we need in order to reach out to the web page and go to it by turning our data into a link. And so I'm going to actually scrape that. It's in the table. It's in the table, it's in the body of the table, and it's under that H element called A and then href. So if we go back to hockey reference, and Ellis right-clicked and clicked on inspect. We've done this a few times in previous web scraping videos, and inspect allows us to see the HTML properties of the web page that we're looking at. And you can see as he's running his cursor over the HTML text in the window there, you can see it's highlighting the elements on the page. And so all I'm doing is I'm finding the attributes and the elements where the information that I need is contained, and I'm just going to go ahead and scrape that from the web page too. And so that's what we did there on line 28. So we go in, we scrape that information, and we turn it into a data frame. And then I'm just going to name it URL info. And I want to make it
Let's take a quick peek at this first,
yeah,
before we get too far along.
yeah. So you can see everything is there except for the hockey reference / leagues / NHL. Except for the information of www.hockeyreference.com. So then it would be /players / the letter B or A or whatever it is, and then their unique player ID. And so that's what we have right there. We're going to turn this into a string, a URL, and then once we get to the app, we're going to turn it into a hot link. So in order to turn this into a string of URL, the first thing I'm doing here is get players. If the pattern says grepl is basically a true or false, so it's going to give me a binary output. It's going to say search within pattern / within that URL info column, and if it's there, put a 1. If it's not, put a 0, right? So if that pattern is located in there, yes or no, put a 1 or a 0, and filter out all of the ones, because there's information there. You can see, for example, line 802, there's information there about the team. And we don't really care about that right now for this app. So we're going to get rid of that. Okay. And then I just drop that column so that it's not in the way. And then what I do here is just a little bit of cleanup where I want to retain certain pieces of the URL. In specifics, I want to get that player ID out of there. So I want to get the actual player ID.html information. I want to snag that information out of there. So that's what I'm doing here, where I'm using some gsub to extract the elements before the dot and extract the letters in between the slash marks and things like that. So we've done a bunch of episodes on regex. Regex is super complicated. If you want to see more, we can leave comments and questions down below. We can certainly get into that. Now we have our cool little player info here. So we have URL info and we have a player ID. That's the information that we require. We're just going to, Ellis put in a little logic check here. Ellis, talk us through what this is doing and why you put it there.
Yeah, so I wanted to just verify that it's entirely possible that there are two players with the same name, right? Like Pat, you and I may not have the same name, but like there's a world where we could have, and we were on a team together, so I just wanted to verify that can we assume that all the players this year do not have the same name, because that changes how you handle things, or relatedly in the app, how are we going to handle, or how does it handle a player that played on multiple teams? I wanted to just quick logic check that in the application here. And so I took skaters. This is a very nested bit of code here. So let me actually pull this out real quick. So first I used the function duplicated, which will return to me a vector of true or falses if a value appears earlier in the data frame, or in the vector. And so this is nice for identifying the second occurrence, or second or more occurrences of a value in a vector. And so here, it's a bunch of falses, but if I do
line 205 there, you had a few trues there at 205.
Yeah, 205 there. I don't know. I'm lazy, so I don't like to look through all of that. So I use the sum function. So when you call sum on a Boolean vector, falses become zeros, trues become 1. So if I knew that if the sum of this vector was 0, there were no duplicates, I'm good to go. But I've got 3 duplicates in this case. So if I throw a which in front of that instead of a sum, that gives me the location of the cases where things are true. So 4, 205, and 206. So then if I say pull out the rows. So that's the row in which there's a duplicated skater. So if I pull that out in skaters and pull the skater or player column out, this gives me the names that were duplicated. So Sebastian Aho and Liam Foudy, and Liam Foudy showed up twice. So we know that Sebastian Aho showed up twice because duplicated tells us the second or more times a player's name occurred, or Liam Foudy showed up 3 times. And so if I do a then taking Skater's player anytime Sebastian Aho or Liam Foudy showed up, pull out that data frame for me, I get this one. So I can see that Sebastian Aho, age 27 and 26, at I don't know what NYI.
New York Islanders.
Oh wow, shows how much I know.
Hmm.
In Carolina.
Hmm.
So I think that's 2 different players because the age is different. But then Liam Foudy doesn't show up multiple times. Or it does show up multiple times, but at the same age. So I'm assuming that they're probably the same person. And we can actually, after we run this bit of code here that Patrick's going to talk through, we can rerun this and double check the logic again to verify, because we would get then a different player ID for different players or the same player.
That's right. Yeah. And so really what this code here is doing is it's taking those player IDs that we scraped out that are underpinning that table. It's making now the actual the URL. It's not a live link yet, but it's basically just pasting together the URL information with the actual website. So we've got those pasted together, and then I just rename that and call it link to player. So now at the end of our data set, we see that our player information web page is there along with their player ID. So now if we do that sanity check of multiple player names, we're going to see that Sebastian Aho is 2 different people. So there's a Sebastian Aho 1 and a Sebastian Aho 2. But we see that Liam Foudy is indeed the same person who just happened to bounce around between 3 teams during this season so far.
So it's just a way to logic check, and how we handle this and how we will handle this in the app will change depending on the type of inputs that we're trying to handle, or what are we expecting out of this application. Where if we just want to be able to throw a player's name in there and call it good, then we're going to get both Sebastians.
Yeah.
Um, or we'll get all 3 records of Liam Foudy. And is that okay? Well, it depends on the application and what you're trying to show.
Yeah. Perfect. So, okay, this is going to be one of the simpler Shiny apps we've ever done. The UI is literally just the 23-2024 skaters. So we didn't retain the goalies. Sorry, goalies. We're going to have a sidebar panel that allows us to select the players. It's labeled players. The choices are going to be the unique player names. Obviously, this is under the assumption that every player is unique. So that's not necessarily always the case. So we just put that caveat there. We're going to have no names selected at the start. And then we're going to allow the user to be able to select multiple people. And then all that's going to be returned is a DT table. We have a DT output in the main table, and we literally call this just table so that we can reference it in the server down below. Again, easiest Shiny app we've ever done. We have an input and an output. We don't even need a session observe event updater or anything like that.
Nope.
First thing that we're doing is we're going to grab the data. So we're going to make a reactive. We're going to query the skaters table and filter out any of the names. Remember, they can select multiple, any of the names that that user has selected. And now, because it's reactive, remember, we're going to need parentheses because it's always going to be updated every time the user does a thing. So we're going to just render this as a data table. Here on line 103, we actually take the link that we have in our table and now we make it hot. Ellis, why don't you talk us through how you make this link actually clickable?
Yeah, for sure. So when you're dealing with data table, one of the really cool things that you can do in data table is include HTML in one of your columns. And when you set the option escape equals false in your data table, it won't try to escape the HTML that you've included into it, and actually will recognize it as true full-fledged HTML and render it as if it were just HTML that was just put in there, or any other part of the web page. So what you can do is you can create these really cool pieces of HTML to include in your data frame, constructed as a string, if you understand HTML. And then when you render it in your Shiny app, it'll be treated like normal. So what you can do is here we're making a link, but I've created data tables that include hover tooltips. So when you mouse over something, it'll create a little hover icon with more information about the thing that you're hovering over. You can embed images. You can include all sorts of pieces of. Basically, you're only limited by the your imagination and knowledge of HTML. And
Your
HTML
HTML, yeah, ability.
HTML is very flexible, and there's a lot of really great tutorials online. If you ever want to spend at least a little bit of time learning the basics of HTML, I do really suggest it. I think that it really improves your ability to generate Shiny applications by understanding the HTML that's going on underneath it.
And so maybe in future episodes, we can do a little bit more HTML within Shiny.
You need to let us know,
And if
though. We
you,
need to
yeah,
let
let
you.
us know if you'd like to see that, because that's the other thing too, is like doing a little bit of that in Shiny and learning a little bit of that for Shiny also makes you better scraping web pages, because you know what to look for when you inspect the page.
Exactly.
HTML. So
It's just you're upskilling in many different areas by just learning a
super
little bit of
helpful.
HTML.
Yeah, exactly.
So what we're doing here is a hyperlink basically. So if you ever see a link in a page, um, usually that's an A tag. It's not always. There's clever ways to link as well in HTML, but this is the like most basic way. So we're going to create an A tag. It needs an attribute href to tell you where it's going to be referencing to. In this case, it's going to be linking out to the player page. We do put the ticks around it so that it's seen as a string, so that it can handle that and treats it as one. Then we put the full on link to player page in there so you can see the full HTML that it'll be sending it to. And then we close our A tag with the caret backslash A. And so we just updated link to player page that column in our data set to be linked to player page. Then we use a select just to reorder things because I want it at the very beginning of my table. Earlier, this was in one of the last columns of our data set, and so it's not easy to see. So I wanted to move it up. So I say I want player name, then I want the link to the player, then I want everything else. And we're going to throw that into our data table. And so now we can rerun it now that we know all the things that are occurring in our Shiny application, all the background scraping that it's doing beforehand, and how now when we select on Adam Ernie, how we made this clickable, how we can just click on this in our DT, and this takes us to Adam's HTML reference or hockey reference,
yeah,
or all these other players,
as
or
many as you want to add. Fill your boots, as they
or
say.
we can look up Sebastian Aho and see showed up twice, and we can see the two Sebastians, the two different teams, or the Liam Foudy,
Foudy, yeah.
and Liam shows up the three times here, but
And his link will be the same.
it's
Yeah,
all linking back to the same location because he's the same person.
correct. Yeah.
And so we can click on
Which is
Liam.
also why his rank in the league is also 204. It didn't matter what team he was on. If you go back to the Shiny app there,
Yeah,
see his rank, whereas Sebastian Aho is two different people, two different ranks, right?
yeah,
I'm assuming that's some sort of ranking of like their player abilities. I could be wrong on Hockey Reference, but
yeah.
I'm assuming that's what it is.
Depends on how you want to look at it, I am sure. There's
Yeah.
probably objective ways too. But that is how you can add a dynamic link that shows up multiple times and add that into your data table to add more interest and capabilities into your Shiny app and somewhat dynamically link back to the player level information.
Which is also good, because if we didn't link back and we were building this for someone, effectively we'd be trying to recreate that hockey reference page. In reality, the purpose of this table might be to just compare a few players. If we're like, let's say, scrolling through and trying to put together our fantasy hockey team, and we just want to compare some players, And if we need extra information, we have the opportunity to click out rather than us building kind of like a slogging website and recreating the wheel of something that's already been done before. We can just give the user the ability to go right to it, which is pretty cool.
Mm-hmm.
Yeah.
Yeah. And so I think in the next episode, what we'll do is we'll connect this application, make maybe some updates to make it a little bit more dynamic per year, and then connect this with our next application or our last week's application that had the games and the teams and find ways to link those up. So that should be a lot of fun. Comment down below how you think we're going to be doing this. I'm
Yeah.
actually very curious what you all think.
Yeah.
So with that, we're going to call episode 163 of TidyX. Thank you for joining us so much. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. I am on X at OSP Patrick. At tidy_explained is, of course, on X, and that's where you can find both of us. But best way to hit us up is YouTube channel, like, subscribe, drop the comments down below as well. If you enjoy the work, you feel like it's helped you, you want to support the show, we do have a Patreon page, which you can get to on the YouTube channel in the comment section there, or in the information section there. And we're always appreciative of anything that you would like to donate.
Thank you all so much and keep on exploring your world.